Okay, guys, here we go. This is our last section of our gas law unit. Okay, so this is called the ideal gas law. The ideal gas law describes the behavior of a gas in terms of the pressure, the volume, the temperature, and the number of moles present, which is going to be represented by the letter N. In other words, in the previous gas laws, Boyle's, Charles, and Gay-Lussac, we were looking at P, V, and T, right? Pressure, volume, and temperature. We're going to add another variable, N, that's going to represent the number of moles, okay? So, now, there's also a gas constant in this new formula. The ideal gas constant, R. Okay, now this is a number that has been experimentally determined. It's a constant. You do not have to memorize this number. It will be given to you in the IB data booklet when the time comes, okay? So check this out. This is the ideal gas law. PV equals nRT. We also, for short, call it PIVNERT, because that's kind of how it sounds when you read it, PIVNERT, okay? PV equals nRT. That is the ideal gas law. Okay, so we got P, which stands for pressure, very good. V stands for volume, perfect. What about T? Temperature. Our new variable N stands for what? The number of moles, perfect. And then R, remember R is a constant. Let me show you the values that R can be. These are the two more common values of R. Okay, so you've got R is either going to be equal to 0.0821 or R is going to be equal to 8.314. Now notice the only difference is going to be in the units. The units for this R are liters times atmospheres divided by moles times Kelvin. The units for this are liters times kPa over moles times Kelvin. They're the same except for the units of pressure. So if we go back to the previous slide says the value can vary dependent on the units of pressure. Okay? So you're going to either use this R if the units of pressure are ATM, or you're going to use this R if the units of pressure are kPa. And of course, you'll know because the question will tell you. And finally, you are going to be able to solve for any of the variables. Remember, how many variables do we have here now? We have P, V, N, and T. There's 4 different variables. R is the only one that's not a variable because R is a what? It's a constant. Okay, it's a constant. That number is always, you're always going to use the same value for R. But P can change, V can change, N can change, T can change. So any question can ask you for any of those 4 variables. Got it? The ideal gas law can be algebraically solved for any of the variables. All right, let's do an example. Calculate the number of moles of a gas contained in a 3-liter vessel at 300 Kelvin with a pressure of 1.5 atm. Notice all the information that's given to you. 3 liters. What are liters? Good. Volume is correct. 300 Kelvin. What's Kelvin? Temperature. Very good. And finally, they tell you that the pressure is 1.5 atm. So what are they asking for? What are the number of moles? What's the letter we're using to represent number of moles? N. Very good. All right, so let's go ahead and work out this problem. So what do I want you to do every time? I want you to write down the formula. PV equals N times R times T. Next, what do I want you to do? Write down all your variables. P, V, N, R, and T. Do we have a pressure? Yes, we do. 1.50 atm. Do we have a volume? Yes, we do. 3 liters. Guys, make sure that you know these units by now. If you don't know atm is a pressure, there's a problem. If you don't know liters is a volume, you got a problem. You got to study that chart that we have in our notes. Okay. Remember that the question asks for moles, so I don't know the moles. We'll come back to R in just a minute because in the problem they give us a temperature. The temperature is 300 Kelvin. Okay, so now R. Let's go and see which R are we going to use. Go back. Here's our two values of R. Do you think you're going to use the one that has units of ATM for pressure or the one that has units of kPa for pressure? Which one makes sense given the information that you are given? If you said that you are going to use this R value, you are correct. Why? Because ATM. And the question tells you ATM. So R is going to be 0.0821. The units, liters times ATM over moles times Kelvin, all of it. Don't leave anything out. You need all of those. Those are the units of R, every single one of those. I'll show you why when we solve for N. Okay, now, what do I want you to do? Step 3, get your unknown variable isolated. Get N by itself. So algebraically, whenever you're trying to isolate a variable, you need to get rid of the other two numbers or variables that are there. I want N by itself. These are all being multiplied. So I'm going to divide by R and T on both sides. R cancels, T cancels. What do you have? You have PV over R times T equals N. You have all of these. You got P, V, R, T. You got them all. Plug them in. What's P? 1.50 atm. Don't forget your units. I know some of you guys like to cut corners and leave out the units. Don't do that. Multiply by the volume. What's the volume? 3 liters. Divide it by, in the denominator, you got R. Now, R is all of this. 0.0821 liters times ATM over moles times Kelvin. I'll show you why that's so important in just a minute. And finally, you're going to multiply by the temperature, which is 300 Kelvin. There you go. Now watch. ATM on top, ATM on bottom. Liters on top, liters on bottom. Kelvin on top, Kelvin on the bottom. Yes, that is considered the denominator of the denominator, so they cancel. The only unit left over is moles. Perfect. That's what we want. That's what we're looking for. We're looking for moles. So you're going to plug in your calculator. 1.5 times 3. Let me grab a calculator. Let me turn it on. 1.5 times 3. That gives us 4.5. in the numerator. Okay. And in the bottom, 0.0821 times 300. What does that give us? 24.63. All right. Divide those. 4.5 divided by 24.63. 4.5 divided by 24.63. What does that give us? 0.18 rounded to the hundredths place. And the units, remember, the only units that didn't cancel are moles. So that's our answer. That's how you solve for moles. You would use any of your algebraic skills to solve for P or V or T, depending on what the question's asking for. All right, there's one example. I'm going to post an assignment. You're going to work on it. And if you have questions, you're going to ask me if you have any questions. Okay?